Welcome back to Advent of Code 2023, day 3. Alright, we're just a couple of hours late, as always, but actually I was earlier than I was yesterday, so that's an improvement. Alright, so yesterday was a better performance, I guess. That was the cubes thing. Alright, let's see what we got today. Gear ratios. Let's zoom in a bit. You and the elf eventually reach a gondola lift station. Sure, let's have a look at the wiki for gondola lift. Yeah. Cool. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. Ah! You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. So 58 and 114 are not adjacent. Every other number is adjacent to a symbol. So what's a symbol? Okay, periods don't count, but everything that isn't. Fine, but what about... Oh, I see. You count the whole thing as one number, 467. But... okay, fine. What is the sum of all the part numbers in the engine schematic? So, turn my table a bit. Better lighting. Okay. It's a bit... well... okay, fine. Let's get the input. So you want to go through row by row. When you find a number, find the beginning and end of that whole number, and then check if there are any symbols adjacent. Symbols means it looks like it's any of the well, you got a minus sign there, but I assume that's a symbol. Yeah, that must be. Alright, let's just try and build this up step by step. So sure that the ID is working this time. Yesterday it wasn't captured on stream, but for the first 5 minutes or something. Right, so that. Okay. Alright, so let's say we have a grid equals that. Here we just want grid dot append line dot strip. We don't need to enumerate. That's all. That captures the input. And now we need a helper method here. We want given a location, we want to find the neighbors, including diagonals. Let's write that method first. So to find get neighbors of I and j. So I is the row, j is the column. So for delta in so on di in range, so it's going to be in, it could be -1, 0, or 1, or dj in -1, 0, 1. If di, so skip the origin. So then everything else will be a neighbor because that's all the diagonals. That's 8 different directions. So it'd be yield I plus di j plus dj. Oh, wait, no. Well, first we need to check that whether we're out of bounds. Alright, so if so neighbor I, neighbor j equals I plus di, j plus dj. If so, it's got to be 0 is less than or equal to neighbor I is less than n, and 0 is less than or equal to neighbor j m, as long as it's within bounds. Yield neighbor I, neighbor j. Okay. So that's our neighbor method. Alright, so what we want to do is just, okay, so total is 0, We want to go through, so for row in grid, we want to look through the what's the easiest way of doing this? Alright, let's just do the wait, let's just spell it out fully. So we want I equals 0 while I is less than length m. So if grid, wait, we're not using grid. If row, hang on, we want j in range for I in range n. Don't use I here, use k. No, j is what we're using, j. All right. Okay, so if grid ij equals period, then we just continue. We do I plus equal 1, continue. Not I, j, don't mix these up. All right, so basically that is just going through skipping all the periods. So if we hit a number, or actually let's say if not dot is digit, because we only will find the digits, so symbols as well will skip. All right. So otherwise, we have a digit. Now we want to find the the last digit. So okay, so j2 equals, let's say, j plus 1. So j2 is after j, so encompassing one digit. And while j2 is less than m and grid I j2 dot is digit, then extend it by 1. So now j to j2 is the full number, right? Now we know where the number is. We need to find whether it's neighboring any symbols. Okay. So we want to go through each. So okay, we want to say if any and then we want to check if, so for a neighbor, we want to check if it's dot Let's write a quick helper method here. So not car dot is digit and car is not equal to dot. Just make that a bit more readable. Okay. If any neighbor is a symbol, for neighbor in get neighbors. How am I? This is a. Can I do a double? Hang on, let's try this. So it's gonna be I. Oh, we need another letter. K then. K for K in range starting from J and finishing at J2. Can I actually do that double for loop? I'm not sure that's allowed. It doesn't like it. Let me finish writing what I'm trying to write. So if there is any symbol, it will shortcut when we find one. Then total plus equal int of grid I j to j2. Oh, it does. Is this alright? Will that work then? K is not defined for. Yeah, because. Oh, there's a way of doing this. How is that? How do you. Alright, maybe a better way is just for neighbor in we want to get all neighbors, so we'll just say for in some list get neighbors I for. So summing lists together just concatenates them. So that just will that oh, some you're not allowed to use like that. You can add things together, but you can't. Is hang on, I'm sure there was a way of doing this. I can't remember how to do it. So Python take union of All right. There's a way of doing this using like union with a or iter tools or something. Okay, forget it. We'll just do this. Let's just change this. Get neighbors I J1 J2. So this is gonna specify the J1 and the J2. So neighbor set equals set, and we want for J in range J1 J2. Then we do all this. And then just do neighbor set dot add neighbor I neighbor J. Okay, that will work. So this method is actually finding all the collection of neighbors around a line row segment, and then we just want this to say if any is symbol neighbor for neighbor in is symbol. You can't use neighbor like that. You have to say grid grid neighbor I neighbor J for neighbor I neighbor J in, so it's going to be this, starting from J. We should have used J1, but whatever. Try that then. Forgot to do one thing. And then you have to set J equals J2. Otherwise it's an infinite loop. Alright, 540212, so you're pushing the J iterator after all the stuff you've done. Alright, 540212. Correct. Alright, it was a bit tricky to code. Not sure if there's a cleaner way of doing that. Is there a way to do it without using those iterators? Like, can Python just pick out? I mean, you could do it from the symbols instead. So for each symbol, you sum up all the numbers it's touching. It wouldn't really be different though. No, I don't know. Okay. Part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast though. Maybe something is still wrong? Fortunately, the gondola has a phone labeled help, so you pick it up and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer, holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those two numbers together. This time you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. Consider the same engine schematic again. Oh man. 2 gears. Oh. Alright, this is not much extra work because we've already got something we can use. Alright, so right now we're looking through each number, and then we look to see if there's a symbol adjacent. What we can now do is look for each symbol that's adjacent, and if it's a gear, then we create a hash map where the key is that gear and the value is a list, and in that list we put in our number. So eventually there'll be a hash map which is accumulating for each gear all the numbers that it is adjacent to. And then from that we can work out the gear ratios. Yeah, okay, so it's not much extra work. I thought I was gonna have to range over the gears and try and work out what numbers are adjacent or something. Okay, so here, so we've already worked out that it is adjacent to a symbol. Okay. So that's the part 1 logic. Part 2, we want to check all gears. So for neighbor I, neighbor J in okay, so this is all neighbors around. Let's just say num equals this. So if grid neighbor I, neighbor J is an asterisk. We're on a table here. Let's say let's use a default dict. So table equals default dict on a list, so empty lists by default. So we'll do table, so it's going to be neighbor I, neighbor J, so that asterisk has num inserted. And that will never happen a second time because we're using a set for the set of neighbors, so it's unique. Yeah, okay, so it's good that we're using a set, yeah. For that num, it will happen only one time. Okay, so after we've done this, Well, so gear ratio sum equals 0 for v in table.values. If length v is exactly 2, that means it's a gear. It's by definition a gear. Then gear ratio sum, we add v0 times v1. Correct. Looks like we're building a cloud here of some sort. Is that what is that? Oh, that's the trebuchet. Oh my god, that's actually a trebuchet in ASCII. That's cool. So yeah, that was a good problem. You need to be able to handle 2D grids, and this is a good warm-up because we're going to deal with, you know, pathfinding, breadth first searching, depth first searching later on, probably. We usually do. Possibly some geometrical stuff. So this is really a warm-up. It was tricky to code that because you need to avoid duplicates, for example. If you were to go digit by digit, you'd have multiple digits connected to an asterisk, so you might not get the right number of parts for the asterisk, so you have to be careful. You have to treat an integer as 1. Yeah, I'm trying to think if there's a way easier way of doing that. I don't think so. I think that's... I mean, you can use like string search methods in Python, but even then it won't really be that much easier. Okay. Check the leaderboard. All right. Stats. We're up to 135,000 people have done part 1. And the times, 5 minutes 9 seconds. Yeah, sure. It was fairly textbooky, so I expect people would solve it fast. Okay. Well, that's it then. All right. So, how long did that take? About 30 minutes. Alright, well, as always, if you want to join my leaderboard, I'll paste the code in the YouTube video. I'll be back tomorrow. Each day I try to start earlier and earlier until I actually start on time for the problem, but I don't know if that's going to happen. Alright, see you tomorrow for day 4 then. Bye bye.